Good morning, geometry. So today we are getting into Unit 4 of geometry. And as we discussed at the beginning of the class, there are 8 units in this class. So we are on Unit 4 out of 8, so we're almost halfway through. And Unit 4 is similarity transformations. So we talked about similarity a little bit, but a lot of like similarity transformations basically just means dilations, which we've learned about before. So we're going to be learning a lot about dilations in this coming unit. But today, we're just going to work on ratios and proportions. So we are going to be doing the first 2 pages of these notes. So you may have seen ratios before. A ratio is when 2 quantities measured in the same units are compared. So a ratio might be written like A to B, or you might see it with this colon there, or you might just see it as a fraction. All 3 of these are representations of ratios. And just like with any fraction, you want to write a ratio in the lowest terms, which is what it says there in the bold. Okay, so if I want to write a ratio of the girls and boys in this class, so in the 2 combined geometry classes, I have a total of 30 girls and 27 boys. Those are real numbers. So my 3rd and 4th block classes, all of y'all should be watching this, and you're one of those girls or boys. All right, it says write the ratio of girls to boys. So, girls to boys. This is going to be my numerator, and this is going to be my denominator. And this 2 in the middle, we can basically think of that as like our fraction bar, or if we're writing a ratio like this one in the middle, basically like our colon. So let's see. If I have 30 girls to 27 boys. Boys are the denominator, girls are the numerator. I want to reduce this fraction, so I need to find a number that goes into both of these, and sometimes it's not going to be able to be reduced. But I know that 3 goes into both 30 and 27, so I divide both of them by 3, and I get 10 over 9. And I can't reduce that anymore, so my answer would be 10 over 9. So the ratio of girls to boys in my 2 geometry classes is 10 over 9, or 10 to 9. And another way I would write this, I'm going to write it in this form in the middle here. So you would just say 10 colon 9. And the only issue with this last form, usually when you, or always when you see this, it's going to be a ratio, but the only issue is that sometimes it looks like a time. But fortunately, if it's 10 to 9, that doesn't look like a time because we would have to say 10:09 if we were talking about time. And another type of problem we might see is something like this, where it says write the ratio of boys to the entire class. So the last one was girls to boys. This one is boys to the entire class. So my boys are going to be my numerator, and the entire class is going to be my denominator. And this 2, as always, is my fraction bar. So the boys, 27, and the entire class, well, That's girls and boys. So 30 plus 27. Let's see. So this is going to give me 27 over 30 plus 27 is 57. So I have 57 geometry students altogether. And now I just want to reduce this. And just like with the last one, I know that 3 goes into both 27 and 57. 27 divided by 3 gives me 9. 57 divided by 3 gives me 19. So the ratio of boys to the entire class is 9 to 19. And to write this in ratio form, I would say 9, 19, and see how that can look like a time. So that's why we sometimes avoid that form. Okay. So we also have these extended ratios. And an extended ratio is going to be a comparison of 3 or more quantities. And it's going to be written like this. And the reason it's written like that is because we can't have a fraction with 3 values in it. So I wouldn't be able to say A over B over C. That doesn't make sense. So you would have to write it in this ratio form if it's an extended ratio, if it has 3 different values. So the ratio of the measures of the angles in a triangle is 6 to 7 to 5. We want to find the measures of the angles. So when we're given a problem like this with a ratio, what we're going to do is we're going to put a variable behind each of those numbers. So I'm going to say, well, my ratio is 6, 7, 5. So I'm going to say 6x plus 7x plus 5x. And it's going to be the same variable for each. And this is asking about angles in a triangle. And I know angles in a triangle have to add to 180. So 6x plus 7x plus 5x equals 180. So, let's see, 6 plus 7 plus 5 is going to give me 18. So 18x equals 180. Divide both sides by 18, and I get x equals 10. But I'm not done with this problem yet, because it told me to find the measures of the angles. It didn't tell me to find x. It told me to find the measures of the angles. But I know that these are going to be my angle measures, 6x, 7x, and 5x. Because if I divide each of them by x, I get this 6, 7, 5 ratio. So what I'm going to do is just, 6 times x, or 6 times 10, is 60 degrees. 7 times x, or 7 times 10, is 70 degrees. And 5 times x, or 5 times 10, is 50 degrees. So these are my 3 angle measures. And we can confirm that by doing 60 plus 70 plus 50, making sure it adds up to 180. And it does. Okay. Up next, we have this problem. It's saying the ratio of 2 complementary angles is 5 to 10. Find the measures of both angles. Remember, complementary angles add up to 90 degrees. So I'm going to do the same thing here. And it says 5 to 10, but really they should have reduced this ratio more to 1 to 2. But we will do the same thing we did on the last one. I'll just do 5x plus 10x equals 90 because they're complementary this time. You need to read the problem carefully to see what it's asking about. So I'm going to combine my like terms. That gives me 15x equals 90. Divide both sides by 15. Let's see, x equals 6. But it said find the measures of both angles. So my two angles are going to be this 5x and this 10x. So 5 times x, or 5 times 6, is going to give me 30 degrees. And 10 times x, or 10 times 6, is going to give me 60 degrees. And those are my answers, 30 degrees and 60 degrees. And those are complementary angles because 30 plus 60 is 90. So we need to pay attention to what type of angles, or what in general it's asking us about, what they're going to add up to. I feel like that's where we're going to make a lot of mistakes in this type of problem. But continuing on, next we have proportions. And if you were in my class last fall, my Algebra 1 class, I know that you know proportions, and I know that we spent like a whole day or two solving them. So you better be good at this. A proportion is an equation that states two ratios are equal, or two fractions are equal. And we have our cross product property, which says for any proportion A over B equals C over D, then A times D equals B times C. And another way to think of that, which I'm sure a lot of you have used this term before, is the butterfly method. That B times C is going to equal this A times D. So you multiply those two together, and then you solve your proportion. So the cross product property is also known as the butterfly method. Okay, so let's look at some problems here. So I'm going to multiply these two numbers together and then these two. So 4 times 7 gives me 28. X times 5 gives me 5x. I divide both sides by 5. And if you do this, you're going to get a decimal. So we can either just say x equals 28 over 5, or we could say x equals 5.6, which is the decimal you would get. I don't mind if you write things in decimal form as long as it's not a repeating decimal. If it's a repeating decimal, please leave it as a fraction. But this is just 5.6. It stops after the 6. There's nothing after that. So this is something that I can write in decimal form. And there are going to be some on the worksheet I have y'all doing after this that would be repeating decimals, so just going to leave them as fractions. And that's how we would solve for x there. We need to pay attention to what type of problem it's going to be, because I have a feeling that some people are going to try to simplify these ratio problems. It's going to be like this one here where it's 9 over 19, and so you're going to type that in your calculator and get like whatever decimal that is and tell me that decimal is the answer. It's not. 9 to 19 is the answer. This is a ratio. These are proportions. Proportions we solve, ratios we don't. Ratios we just simplify. Okay, number 5, let's see. I will multiply these two numbers together and then multiply these two numbers together. That gives me 3 times y, which is 3y, equals 2 times y plus 2. So 2 times y plus 2. I'm going to distribute this 2. So that gives me 3y equals, 2 times y is 2y. 2 times 2 is 4. And I will subtract 2y from both sides. That's going to give me y equals 4. So there's my answer, just y equals 4. This one, I don't need to write it as a fraction because it's just 4. I should probably circle this one too. All right, proportions. Hopefully we've seen them before, but this is just to review them. Okay, on to the next page. We have some word problems. And this says a recipe calls for 3 cups of flour for 48 cookies. How much flour is needed for 72 cookies? Now, I know that on the first page, it's that a ratio would always be measured in the same units. But here we have 2 different units. We have cups of flour and we have cookies. So a ratio, in this case, we are going to write it as a ratio. It doesn't matter that they are in different units. So I'm going to do, let's do cups of flour over cookies. These are my 2 things that I'm measuring. I have 3 cups of flours. So my cups of flour is my numerator. Cookies are my denominator. So 48 cookies. And it says how much flour is needed for 72 cookies. So let me set this as a proportion. Since it's asking how much flour, and flour is my numerator, this means I'm going to have x in my numerator because I want to solve for this number. I don't know how much flour I need. And 72 cookies, I put the 72 in the denominator. And now I will use that butterfly method. I'll multiply these 2 together and these 2. So 3 times 72 is, what is that? 216. And 48 times x is 48x. And now I divide both sides by 48. And that's going to give me 4.5 equals x. So the question was how much flour is needed for 72 cups. So I would say, or 72 cookies, I would say 4.5 cups. And that would be my answer. You do not need to answer this in a complete sentence, but since this is a word problem, I would like to see some units. Okay. Our next problem, I have a picture that has a length of 6 inches and a width of 4 inches. So first things first, length of 6 inches, width of 4 inches. These are my 2 units. This is what my proportion is going to be. I could do length over width. I could do width over length. It does not matter when I set up my proportions, as long as my second proportion is the same thing. That's why I wrote it out like this up here, because I had cups of flour on the top and cookies on the bottom. If you'd done cookies on the top and cups of flour on the bottom, that would work as well. But it would need to be the same in both of your proportions. So I could say 48 over 3 equals 72 over x. I can't say 48 over 3 equals x over 72. That wouldn't get me the right answer. Okay, so I'm going to start by just saying L over W, length over width. If you want to enlarge the picture so it is 20 inches long, how wide will the picture be? So 20 inches long, that's length, and it's asking how wide will it be, so that's the width. So let's see, the picture is a length of 6 and a width of 4. So my first proportion would be 6 over 4, or my first ratio, I guess, is 6 over 4, length over width. And that's going to equal, let's see, it was 20 inches long, so it's a length over x, because I don't know what the width is going to be. So I'll use my butterfly method. Six times x is 6x. 20 times 4 is 80. And if I try to solve this, it gives me x equals 13.3 repeating. That doesn't make sense. I'm not going to like go to, I don't know, Michael's and say, hey, can I get a picture frame that is 13.3 repeating inches? No. So what we would do with basically only these types of problems, well, actually, another way I could write this would be 40 over 3, but I'm also not going to say, can I get 40 over 3 inches? No, that doesn't make sense either. So the way I would write this, remember that 0.3 repeating is 1/3. So I would say 13 1/3 inches. This is the only type of problem where I would want you guys to write it like a mixed fraction like that. Just think about the context, think about if it makes sense. On the last one, I could have written this as 4.5 cups, and I would probably say it verbally like 4.5 cups if I was talking about a recipe. But 4.5, everybody understands that 4.5 is the same as 4.5. This one, 13.3, I would just say 13 1/3. Okay. And then we have a geometry application of this concept of ratios and proportions. So the ratio of 3 side lengths of the triangle is given. Solve for the variable. So the ratio of AB, and AB is 3x, AC is also 3x, and BC, which is x plus 4, is 3 to 3 to 5. So earlier, I said that we can't write this extended ratio as a fraction, but we could write it as a bunch of separate fractions. So this 3, 3, and 5, what if these are my numerators? And then this 3x, and x plus 4, these can be my denominators. So, let's see. The first one is the 3, and the first one over here is 3x. So I would say 3 over 3x. The second one is 3. The second one there is 3x. So equals 3 over 3x. And then the third one is 5. The third one there is x plus 4. So equals 5 over x plus 4. Now I have 3 things that are equal to each other. And if we're given something like this, typically it won't matter which of the 2 I choose. So I could just pick any of these 2 and solve that proportion. I don't have to use all 3. It's just like when we were solving the sides of equilateral triangles. So I don't have to pick all 3. However, I see here that these are the exact same thing. So if I try to solve with those 2, everything's going to cancel out and I'm not going to get any answers. I'm just going to get 9x equals 9x. That doesn't tell me anything. So instead, I'm going to go with these 2 here. So I'll use my butterfly method. So 3 times x plus 4 is 3 times x plus 4 equals 3x times 5. And 3x times 5 is 15x. I will distribute my 3 inside the parentheses. Gives me 3x plus 12 equals 15x. Subtract 3x from both sides. 12 equals 12x. And I will divide both sides by 12. 1 equals x. And it asked me to solve for the variable, so I'm done. If it had asked me to solve for the side lengths, I would just plug it back in. So I would do like 1 plus 4, or 3 times 1, or 3 times 1. But my answer here is just 1 equals x. And this is the extent of today's notes. Now, before you stop watching this video, let's look at today's activity, because I'm going to make some, or give you guys some help with it. Okay, so this is what today's activity looks like. It is 20 questions, and I'm going to help you guys set some of these up. So numbers 1 through 6, you're just writing the ratio. You don't need to turn it into a number, but you do need to simplify the ratio. And looking at number 5 here, it says the hockey team played 82 regular season games last year. If they won 44 games, what is the ratio of wins to losses? It doesn't tell me the number of losses, but it tells me the number of games they played, and it tells me the number of games they won. I'm going to assume that there weren't any games that they tied, but the way I would set this up is 44, because that's the number of wins, over, let's see, 82, because that's the number of total games played, minus 44. You would do 82 minus 44. That would give you a number. And then you would have to simplify that fraction. You can either leave it in fraction form or write it as a ratio. Either way, that's fine. And that applies to all of the first 6. Let's see. For numbers 7 through 12, I'm going to help you guys set some of these up. For number 7, the ratio of the measures of 2 complementary angles is 7 to 8. Complementary means they add to 90 degrees. So this is the type of problem where we're going to do the 7x plus 8x equals 90. And that's how you would set up number 7. For number 8, 2x plus 9x plus 4 equals 180 because it's the angles inside a triangle. Number 9 also adds up to 180. However, pay attention to what it's asking you. For number 8, it says find the measures of the angles. So it wants you to find all 3. You should have 3 answers. For number 9, it says find the measure of the largest angle. So the largest angle is just going to be this one with the 10. So once you solve for x, you would just do 10 times x, and that would give you your largest angle there. For number 10, so the ratio of the measure of the vertex angle to the base angle of an isosceles triangle is 8 to 5. Find the measure of the vertex angle. So remember, with these isosceles triangles, we have 1 vertex angle and 2 base angles. So even though it only says 8 to 5, there are actually 2 5s there, because the other one would also be 5. So you would set this one up like 8x plus 2 times 5x equals, and let's see, they add up to 180. So there we go. So that's how you would set up number 10. And to find the vertex angle, you're just going to solve for x and then plug it into that 8x. And then 11 and 12 are both perimeter problems. So these aren't going to add up to 180 or 90 or any of those common measures we've been working with. So this one just says 21 to 8 to 14. So I'm going to do 21x plus 8x plus 14x. And the perimeter is 215, so equals 215. With perimeter, it doesn't have to add to 180 or 90. I think a lot of people have been confused on that. I know a lot of people have been messaging me on Schoology saying like, oh, I checked my work, I tried to check my work, and I added up the sides and they didn't add to 180, so where did I go wrong? The sides don't have to add to 180. The angles do. So pay attention to if it's asking about sides or angles. And 12 would be the same thing. 4x plus 7x plus 5x is 128. As for the back, earlier when we were doing the notes, I said that we're going to see some where you can write them as decimals because the decimal stops. But there are also going to be some that I want you to leave as fractions. And on this page, only 2 of these 8 problems are going to be whole numbers. 2 of them are going to be decimals that stop, so you can leave them as a decimal, but 4 of them are going to be fractions. So 15, 16, 17, and 19. Those 4 I just circled, leave them as a fraction. There are 2 others on here that you could leave as a fraction or a decimal, and then 2 that are just going to be a whole number. Okay, so hopefully that clears up any confusion, but if you have any confusion, please message me on Schoology, let me know. I'm more than happy to help, or come to my office hours today. And I will see you guys tomorrow.